We are Alchemia-nova, a research institute focused on closing nutrient loops. Our contribution to the WATERAGRI project is the development of a bio-inspired, multi-layered drainage filter. This filter will be used to retain nutrients and water from agricultural runoff. The problem we want to mitigate with our technology is that due to climate change, the frequency of severe droughts and short but heavy rainfalls is expected to increase. The dry soil won't be able to take up this large amount of water in a short amount of time. This can lead to an increased runoff and flooding of the fields. When fields are flooded, a layer of water can stay on the field and suffocate the living organisms in the soil, which are important for soil fertility, such as microbes and worms. It also damages the plants, leading to a decrease in crop growth and subsequently the harvest. A traditional way to remove surface water from fields is drainage. Drainage is basically the removal of water from soil via sloping ditches, canals, or pipes, leading into a basin or directly into near water bodies. The discharge from drainage can contain high amounts of nutrients such as phosphorus and nitrogen from fertilization. Discharging this runoff untreated can lead to algal bloom and thus a depletion of oxygen and a decrease in biodiversity in near water bodies. Therefore, we want to treat this discharge to keep the local water bodies and ecosystems intact. We want to reach this goal by filtering the runoff through a material with the ability to recycle nutrients and retain water. 2 filter systems will be developed and tested in the course of the project. The systems will be placed at the end of the drainage and consist of several layers. One system will consist of a planted biofilter or constructed wetland with added biochar and layered with structural material. The other system will consist of biochar sandwiched between structural material. Biochar is basically charcoal made by pyrolysis, which is the burning of biomass, such as organic waste or wood, without oxygen and at high temperatures. Biochar is highly investigated as an additive to soil, but not so much as an additive to planted biofilters. Due to the large surface of the biochar, it can take up water and absorb nutrients, just like a sponge. The biochar will thus take up the nitrogen and phosphorus from the runoff. In the second filter system, we will test how much the biochar can take up until it is full and needs to be exchanged. The first system won't need an exchange, as the biochar will be added to the constructed wetland. A constructed wetland consists of a basin filled with a substrate and plants. It can be filled with water either all the time or on occasions, as in our case. Constructed wetlands are regularly used for the treatment of wastewater. In constructed wetlands, water is cleaned by a biofilm. A biofilm is a thin but robust layer of mucilage containing a community of bacteria and other microorganisms. The plant roots provide a surface for the biofilm to stick to, as well as oxygen. Plants can also use the water stored in the wetland to grow and re-evaporate it over time during hot periods. This can lead to a better microclimate in the local field area. Not all water can be retained during heavy rainfalls. This filtered water will be redirected to storage or to the groundwater. When the plants are grown, they can be harvested and composted or directly used as mulch to fertilize the field. The nutrient-loaded biochar can also be added to the field. Thus, less artificial fertilizer will be needed and the nutrient loop is closed, as the washed-out nutrients can be reapplied. Alchemia-nova will install a prototype of the filter systems at the sloping fields of the farm school site in Mistelbach, close to Vienna. The optimized filter systems will then be demonstrated in Gleisdorf, close to Graz. The field site uses a pipe system for drainage. We are glad to develop a system to help the recycling of agricultural wastewater and thus reduce water contamination and contribute to tackle the growing problem of water shortage. Thank you for your attention, and feel free to contact us for more information.